go section 9.4 for geometry. It's called the tangent ratio. It is one of three extremely important ratios. The other one's sine and cosine, which you'll learn in the next section. And just as a comment, 9.3 was left out on purpose. It's got a lot of really cool geometry in it, but none of it's really critical for you to know. And it's also not on your assessment. Whether you're online or brick and mortar, it's not on your assessment. So I don't think we're going to cover it for the sake of saving time. And it really is cool stuff, but boy, it takes an awful lot of effort to get it, and it's not all that useful. So we're not going to do it. Section 9.4, the tangent ratio, goes along with sine and cosine, which is in section 9.5, which that'll also be included. So let's just jump right to it. The word tangent, there's a reason that they use that word. Tangents to circles and curves and stuff like that. It's related to it, but I'm not going to go into that. We're just going to call it the tangent ratio, and it only applies to right triangles, at least for right now. It will only apply to right triangles. And if you have a right triangle, any old right triangle, not a special one like we did last section, no, not special, just any old right triangle, and this is A, we'll call this A, and this B, capital B, and this one capital C, then what we do is we put the sides that are opposite of these, like A, here's angle A, we go out here to the opposite, I'm going to call that little a, and that will be the length of that side opposite A. B will be down here because it's opposite of B, and C will be up here. And then it will look like A squared plus B squared equals C squared. That's the way we always line things up. So we always let capital C be the right angle, little c be the length of the hypotenuse. And if that's the case, then by definition, the tangent is what we're talking about, only tangent, not sine and cosine. By the way, you only take the tangent of the two acute angles, never the right angle. You will never take the tangent of the right angle in this class. You will when you actually take the course called trigonometry, but we're not going there today. So for us, you will only take the tangent of A or the tangent of B. So let me give you both of those, and then I'll talk about it. The tangent of A, an angle always follows the word tangent, and tan is short for it. You'll see it on your calculator. Over towards the right side of the stuff. It's right above that. It's above the number 9, not right above it, but the one above that. Anyway, an angle always follows the word tangent, and the tangent of A is equal to A over B. And the tangent of B, angle B, whoops, not tab. The tangent of angle B is equal to B over A. In general, the tangent of an angle, I'll just put, they always use the Greek letter theta, and theta it's pronounced T-H-E-T-A, theta, and it looks like this. When they want to use an angle in general, they'll use that sometimes, quite often. So the tangent of any angle theta is going to be the opposite side over the adjacent side. Adjacent means attached to. So, let's see if I got that in there. Okay. So what I'm saying is if we focus on, we say tangent A. So the first thing your eyes better go find is angle A. There it is. There's angle A. And the tangent is going to be defined to be the side that's opposite that, A, over the side that's adjacent to it, B. You will never, in the tangent ratio, this will never come into play. Sine and cosine, absolutely, but not for tangent. Tangent's all about the legs. So the tangent of A is the opposite side A over the adjacent side, meaning attached to A. B is attached to A. It's one of the sides that makes angle A. So it would be A opposite over B adjacent. Now, if you're doing the tangent of B, you need to get your eyeballs on B and then find its opposite, which is B, over the side adjacent to it, which is A. C is not in it. It's B over A. So these are reciprocals of each other. Okay, so let's try it. Example 1 says to take a triangle like this. It's a little skinny guy like this. And the right angle is here. And it says this is 18, this is 80, and this is 82. Like that. And it says, oh, we've got an S, T, and R. Like this. Here's what it says. Find the tangent of S and the tangent of R. Tangent of S, tangent of R. Oh my goodness. There we go. Now you can see it. So what I do is I look at the tangent of S. I look for S. There's S right there. There's this S angle. There's the angle S. I want to go opposite 80 over adjacent 18. Reduce that if possible. You want to put it in reduced form. If you can't reduce that, or you're not willing to try, or you're just not quite sure what to do, you take 80 divided by 18 in this calculator, and then go math. Enter. It says answer to fraction. You say yes by hitting enter. So it's math, enter, enter. And you get 40 over 9. Okay, the tangent of R. Tangent of R. So get your eyes on R. There's R. This angle right here is R. And the tangent of it is equal to the opposite of R, 18, over the side adjacent to it. And you're going, but 82 is also adjacent. This always has the name hypotenuse. This is never an adjacent side. Nope. It's the leg that's attached to it. One that's attached to this angle is the hypotenuse, and he is always the hypotenuse. So opposite 18 over adjacent 80 has to be another leg. Has to be 80. And if we reduce that, we get 9 over 40. And they're reciprocals of each other, just like we saw up here. So that's exciting, right? Okay. Example 2, now we're actually going to use it to solve something. That was example 1. Example 2 says, here is a triangle, looks like this. Excuse me. And it's got an 11 here, and an X here, and a 32 degrees here. And the instructions are, find the value of X. Round the answer to the nearest tenth. So now is where tangent starts to become useful. Up here we were just practicing with it. Now we're going to make it useful. And this is what I would write. I would take the angle that I know, or that's written there, and I would write a tangent ratio for it. I would say the tangent. Notice I haven't got any letters on here. We don't need letters. I'm going to take the tangent of this angle that they gave me, so I'm going to put a 32 back here instead of a letter. Equal. So the tangent of this angle, 32, this angle right there, is opposite over adjacent. You're going, well, how does that help me solve for X? Well, I'm here to tell you, the tangent of 32 is just a number, and it's a number that your calculator knows. So think of this whole thing as just a number like this. If I had, just go with me on this for a minute. If I had something like 41 equals 11 over X, what would you do? Well, you would put 41 over 1, and then you cross multiply. You get 41X equals 11. And then divide by 41. That's exactly what we're going to do here. This is a number. It's just a number. The whole thing is just a number. If I put it over 1 to make it a proportion, then I would say tangent 32 times X equals 11. Now, here's a problem. This is called ambiguous, and in all of math, we try to avoid being ambiguous. The reason what I wrote here is ambiguous is because if I take the tangent of 32 times X, the question becomes, do you want to take the tangent of 32 and find that number and then multiply that number by X? Or do you want to multiply 32 times X and whatever that is, tangent that? Since it's ambiguous, we are not going to put the X there. We're going to put it here. Then it becomes very clear that we want to take X times the number, tangent 32, which is precisely what we want to do in the cross multiplying. So we're not going to put X on the end. We're going to put it in the front. That'll be typical. That's going to happen to you a lot. When you go to cross multiply, you put this guy on the front of the tangent to avoid the ambiguity. So I get X tangent 32 in that order, 1 times 11. Then, to truly solve for X, just like over here, when they had the 41 by it, I'm going to divide 11 by the tangent of 32. And then, and only then, when you get it to here and X stands alone algebraically, you get all the algebra first. Do not start here and grab that calculator. Do not grab your calculator until X stands alone. I promise it'll avoid all kinds of problems for you. Then the next thing, you probably have to do this once, but in this mode key, and it happens in all calculators, in this mode key right here, or in a mode key on some other calculator, you want to make sure you're in degree mode. So in this calculator, it's mode. You go down to the third line, it says radian degree. I already got mine in degrees, but if it were in radian mode, it would have looked like this. So I would go down to this, go over to degree, and hit enter so it's choosing degree. Because if you're not in degree mode, you're going to get all messed up. Radians is a whole different ballgame. So make sure that's the case, then get back out to your home screen and you go 11 divided by tangent, and tangent key is right here. Tangent of 32. Close that parenthesis on the end, because let me try that again. 11 divided by, and when I hit the number tangent, it automatically slaps down a parenthesis right there. So you got to put what you want to tangent, make sure you get in a habit of closing that parenthesis. Then enter, and you get 17 point, x is approximately equal to 17.6. And we're rounding to the nearest tenth, if you'll recall. So that's the length of x, 17.6, where this is 11, if this is only 32. So let me go over it again. We had this diagram, and it said find x. That's all it said. So we got to look at these, and you say, with respect to this angle, if I'm looking at that angle, what I have is an opposite and an adjacent. So I'm going to choose tangent. That's all we're doing today anyway. So you write the tangent of the angle equals the opposite side 11 over the adjacent side x. Then you make it into a proportion and cross multiply. And in cross multiplying here, you put x out in front of the tangent of 32. So x times tangent 32 equals 1 times 11. Then remembering the tangent of 32 is just a number that your calculator knows, you solve for x by dividing by the tangent of 32, and then, only then, do you grab your calculator, take 11 divided by the tangent of 32, making sure you're in degree mode, and round to the nearest. Okay, let's try example 3. This one says we've got a triangle that looks like this. Sorry, let me stand that up. Right, got a right angle here. This is a 1, this is a root 3, and this is 60. This isn't like the other one. This one says, use special right triangles to find the tangent of 60. 60 is one of the angles in a special right triangle. The tangent of 60 is angle. The tangent of 60 is going to be its opposite, root 3, over 1. But anytime you write something over 1, it is just that thing. So we now know that the tangent of 60 is the square root of 3 every time. Now let me show you that that's true. If I take the tangent in my calculator, if I take the tangent of 60, I get 1.732. Well, that's supposed to be root 3, so let's see what root 3 is. The square root of 3. Oops, I don't need that parenthesis, sorry. The square root of 3 is, oh, look at that, exactly the same thing. The tangent of 60 degrees is root 3 because we have a special right triangle and it's opposite over adjacent, which is just the root 3. So in perfectly exact form, the tangent of 60 is root 3 using special right triangles that we learned about last time. Okay. One more example, and it is one with some context to it. It's example 4. Found on page 490, and it says this. You are measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59. Find the height h of the tree to the nearest foot. Holy camole. We got to draw all that. Most of the time, they'll give you the information, and you're going to have to draw it. So here's the tree. You don't actually have to draw a tree, but I'm going to. Okay, so there's my tree. And you may assume, you have to assume, as a matter of fact, that the tree is growing perpendicular to the ground. So there's your right angle. And then you're out here somewhere, standing right here. Actually, we're not going to take into account your height. So we're going to put whatever you're sighting with right on the ground. And looking up to the tree, the top of the tree is 59 degrees. That's what it says. So let me read that again. It says, you're measuring the height of a spruce tree. So we want to know what this is, the height of the tree. You stand 45 feet. Oh, this is 45. Stand 45 feet from the base of the tree. You measure the angle of elevation, meaning if you have to raise your eyes up to look at the top of the tree, that's this angle right here. Angle of elevation to be 59 degrees. Now, we got all that information. Let's find the height of the tree to the nearest foot. So if you take a look at what we got this angle. We want to know the opposite of that angle, and we have the adjacent to that angle, so tangent. We say the tangent of 59, that's the angle, equals the opposite x over 45, the adjacent. Then remember what we do. We make a proportion out of it, and we say 45 tangent 59 equals x. Now, in the previous example, this one right here, we had, when we cross multiplied, we got x tangent 32 equals 11. We had to do one more step, and that was divide. That's not the case here. When we cross multiply here, we get 45 times the tangent of 59 equals x. So x is already by itself. Now you can grab your calculator because x stands alone. And we just do this, 45 times the tangent. I don't know if you can see that. Sorry about that. I'm going to put it over here next to this. So it will be 45. Oops, got to try that again. Let me clear out the whole thing. 45 times the tangent of 59, close the parenthesis, enter. 74.89 is what I get, plus another bunch of junk. It's approximately that, but it said round to the nearest foot. So I would say this is a 75-foot tree. Okay? So that's the end of that. Those of you doing the assignments for me in my class, the assignment is on page 491. And I want you to do 1 through 23 odd. Include 14 in that. So stick a 14 in there in the midst of that. It's going to be in there. So 1 through 23 odd, and on your way through, hit number 14. That's 12 problems. It won't be very hard, all using tangent as your solution method. So there you go. And your next lecture will be on sine and cosine, and that'll be a lot of fun as well. So we will talk to you later.